Welcome to my presentation on division strategies. In this lesson, we will explore different ways to think about division, including division decimals, using place values, interpreting remainders, and applying division in measurement. These strategies will help us see how division connects to real-world situations and how precision in measurement matters. By the end, you'll see how division is not just about numbers, but about understanding groups, parts, and fairness in sharing. On this slide, we are dividing 5.10 by 2. First, I think of 5.10 as ones and 1/10. I split the 5 ones evenly into 2 groups, which gives 2.5 for each group. Then I take the 10th, or 0.10, and divide it by 2. That equals to 0.05. When I add 2.5 and 0.05 together, I get 2.55. So 5.10 divided by 2 equals 2.55. Now let's look at how we solve 5.10 divided by 2 using long division. First, 2 goes into 5 2 times, which gives us 4. We subtract 4 from 5, leaving 1. Next, we bring down the 1 from the tenths place, making it 11 tenths, or 1.1. 2 goes into 11 5 times, which gives us 10. Subtracting leaves 1 again. We bring down the 0 from the hundredths place, making 10 hundredths, or 0.10. 2 goes into 10 5 times exactly, so the final quotient is 2.55. Now we're dividing 75 by 3. First, we represent 75 with 7 10 rods and 5 ones. We need to split these into 3 equal groups. Each group gets 2 10 rods and 5 ones. That makes 25 in each group. So 75 divided by 3 equals 25. Now let's divide 10 by 3. We start with 10 ones. When we divide them into 3 equal groups, each group receives 3 ones. That uses up 9, leaving 1 left over. We can say the answer is 3, remainder 1, or write the decimal 3.33. Here, we're solving 10 divided by 3 using the Common Core process. First, we see how many times 3 can fit into 10. 3 goes into 10 3 times, which makes 9. After subtracting, we have 1 left over. The 1 is called the remainder. If we keep dividing, we bring down a 0 and turn it into 10 again, and 3 fits into 10 3 times, with 1 still left over. This cycle keeps repeating, which is why the decimal answer is 3.3 repeating. So the solution can be written as 3 remainder 1 or as 3.33 with the 3's repeating. Division often happens with measurements. If we have 6 liters of juice and we divide it evenly into 3 bottles, each bottle receives 2 liters. This shows how units like liters or meters can be divided just like whole numbers or decimals. Here we see division in the metric system. Starting with 1,000 grams or 1 kilogram, we split it evenly into 4 groups. Each group gets 250 grams. This shows how capacity, mass, and volume can be divided into equal units using the metric system. Here, we see how division can result in repeating decimals. Splitting 1,000 milliliters into 3 equal groups gives 333.33 repeating milliliters. Since we cannot always measure infinite decimals, we round to 333 milliliters. This rounding shows the level of precision in our measurement. To conclude, In this presentation, we explored division in different forms. We saw how models and drawings make division clearer, how remainders can be expressed in multiple ways, and how division connects directly to measurements in liters, grams, and meters. We also looked at how precision in division tells us how exact our answers are. Division is more than solving problems. It's a tool for sharing fairly, measuring accurately, and making sense of the world around us. Thank you, and have a good afternoon.